Hello everyone and welcome back to this next lecture. So in this lecture we're going to execute the code on the two processors and observe the results. So to begin with, I'm going to bring the microcontroller into the video. So you will see the microcontroller connected in the video. This is the microcontroller which I have connected to my host computer using the USB cable. And there is now to this microcontroller I have connected to a solderless breadboard. So I have connected EPWM pin A, that is EPWM1 pin A, which is GPIO 0, to one part of the solderless breadboard, and I have connected EPWM4A, which is GPIO 6, to another part of the solderless breadboard. I have connected my two oscilloscope probes to the same row so that I can measure the gate pulses. I would always suggest please use this method rather than trying to connect these oscilloscope probes directly to the pins so that you don't break the pins. So now that we are at this stage, let us now start by executing the code. So I'm going to go over first to CPU 1, and here let me now go into the debug mode. Okay, so you will see this error sometimes, and this error is simply because sometimes it doesn't find the necessary files. In such a case, all you have to do is close down Code Composer Studio and open it again. So let me come over here and open Code Composer Studio again. And I'm going to close this down, and let's now again try to enter the debug mode. And you'll see now it works. So this sometimes has to do with the fact when you actually change your directory structure, such as you delete directories and you move directories around, and it stores the configuration JSON file in one of the directories and it can't find it again. Now, in such a case, when you restart your Code Composer Studio, it rebuilds it again, and therefore it finds the JSON file. So this is something that all you have to do, close down your Code Composer Studio and restart it. So I will, as usual, program for CPU 1. And now you will see CPU 1 is in the halted state. It has been programmed, so now we can run the code. So now let's go over to our oscilloscope, and I'm going to zoom into the oscilloscope. And you will see now that we are getting a waveform. So you will get a yellow waveform. You see the yellow waveform is connected to EPWM1A, and you will see because we have selected a 30% duty ratio, you will see that it is on only for 30% of the entire PWM cycle. So now that we've done with this, you can also verify that the switching frequency is 10 kilohertz, right? So again, let me just zoom in a little more, and you will now see below that the switching frequency is 10 kilohertz, right? So let me zoom out a little. Yeah, that should be good enough. And now it is time to program CPU2, or rather it is time to execute the code in CPU2. So first let us connect the target. And after the target has been connected, we then load the program. And here we must load the .out file. So remember, we go to the correct directory, that is a driver lib directory. Within driver lib directory, we go to the CPU RAM folder, and in the CPU RAM folder, we look for the .out file. So this .out file is the final executable. Open it and execute it. So this now means that the file has been downloaded onto the microcontroller, and the microcontroller is in the halted state. This red button means it's ready to go. So we click on it and we click on the continue button. And you will see from the waveform that now we are getting a very similar waveform on EPWM4A. It might feel like this is wrong, but remember these are two totally different CPUs that have two totally different time counters. So therefore they may appear to be phase shifted with each other, but if you take a look here, they both have the same switching frequency, which is 10 kilohertz. And we have chosen a slightly different duty ratio with EPWM4, which is the reason why the on time of EPWM4 is slightly more than on time of EPWM1. So this shows that we now have a simple buck converter PWM going on both our CPUs, one with bit field and the other with driverless. So with this, I'm going to end the microcontroller video, and we are also at the end of this particular section. So in this section, I examined how we can run this, how we can write a simple EPWM, a buck converter PWM for our F28379D. Now, of course, this was very basic. This is merely an extension of the EPWM configuration that we had done in our basic course. Matter of fact, we had done more complex configurations in the basic course, and this will follow very soon in the next few sections. But this is just to get started so that we have a simple code from which we can build on, and in the next sections we'll be using this exact same code to extend our PWM logic to include more complex strategies. So if any of this did not work, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening and see you soon. Goodbye for now.